so very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. That information is not available.
How do? Everyone okay? What's going on, folks? How you devil are you all? So, I couldn't do a stream because I needed to print some stuff off so I could show you and make sure I know which way I'm going with it. So anyway, welcome to Antenna Rotator, number 8, enclosure and drive belt, and maybe, well, some firmware, yeah, firmware work. So let's alter the firmware, because we're using the firmware for the stepper motor driven antenna switch. So now we need to make a new firmware or something, boilerplate. It's only boilerplate code at the minute to put later on into our web interface. So anyway, let's see what's going on the old frequencies. Have a look at that. So anyway, they all seem to be concentrated on one channel. See if there's anyone on 15. Nobody? Maybe one or two. What about... No, nothing there. What about 40 meters? Bit noisy on 40. Bit noisy. Is there anyone there? Don't think there's anyone there. No, what about 20 meters then? 20 meters. Let's get something on. Something to listen to in the background while we're working. Yeah, I'm still aches a bit. Still weird, but I think it's getting better. Either that or I'm getting used to it. Anyway, right, let's just bring this up onto a bigger screen. I've got my old shirt on. This one's dropping the bits, but I am just chilling here. I don't give a, you know. Anyway, so I've had to change this bit. Oof. That was nasty. So it's a hex shaft, and I found this pulley that happened to have a hex shaft, so I made this it's like a pole adapter, so to fit that. But then I couldn't find another hex shaft for a bigger, so I've ended up having to create, let's just undo the stepper motor. So created this thing. I downloaded this shaft because I tried to make my own with the GT2 2mm pitch, and it's not as easy as it sounds to make a 2mm pitch with the right amount of all sorts. I did try for hours. In the end I've resorted to this one, and it just so happens to have a 12mm round with locking nuts and bolts to tighten up onto the shaft. So I made a exactly the same as the one I've just made here, but with a 12mm round and a flat, so you can tighten it up. And I've ordered a pack of belts. So let me just make sure we got audio before we go too far. Hold on a second. Just wait a minute. Just wait. We have audio. Anyway, so I've gone ahead and made the base. You can't see the blackness of this. So we've got this enclosure that takes, it's got DIN rail mounts, can't see because the brightness is really weird in here. Tell you what, let's turn the light on. Turn the light on. Is that any better? Probably not. Oh yeah, just a bit. So you've got here to mount a control panel, and also the stepper motor PCB, which we've got to make yet, on there. And we've got your stepper motor, NEMA 17, with its packer. And you've got, I don't know if that's that. Is that better or worse? I think that's worse. Hang on. Yeah, that's worse. That's better like that, isn't it? Better without the lights on. Anyway, so when I made this base, I made it removable. So the idea of making it removable, I don't know what the idea was really. Oh no, I needed to print it separately. So I needed to print that upside down like that, so I could get these sides on, and then the countersinks. And this bit, I printed it on its back like that, and it printed all the rest of it, and then I bolted it together. And this is, it makes up the enclosure. This is the enclosure to enclose the control panel, the motor, and the driver board. So I've got to print yet the cover that goes on. I've designed it but not printed it, and that fastens here around there. So it hooks round and folds around the back. So hopefully any rain will just run down. Okay. Anyway. Then there's this drive belt and pulley, which I bought a pack of belts, and I've had to use the 300mm belt, so it's 300mm, and you can turn it. So it will actually turn. Doesn't spin any more freely because you're going against the stepper motor, but that's okay. And then when you put the force on it, it still turns. Okay, so it's got some kind of gearing. I can't remember how many teeth it was now. Let me just find out how many teeth it was. 27 tooth. Is that right? Hang on. It's more than 27 tooth, isn't it? T5 27 tooth. Yeah, must be 27 tooth. I can't see that being only 27. It's got to be more than 27, that has. That's got to be more than... You can't see it. Let's bring this over here so you can see it. Yeah, this is more than 27 teeth, surely. Let's try and count it, roughly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, I don't know how many teeth it was now. It's saying it's 27 teeth. And that's obviously not correct. Right, weird. Why does it say 27 teeth? I don't get that. Anyway, I don't know how many teeth it is now. Don't know how many teeth it is. So anyway, I made another one of these. I threw the other one away. There you go. Yeah, so I printed one out, and it wouldn't quite fit the belt. This one. It was holding the stepper motor further over, and this one, the new one, does it just right. So there's no tensioning to do. It holds it exactly right. Okay. Well, there's difference between this one and that one is 5mm, 5.5. So I don't need that anymore. So that goes into the scrap bin. Anyway, so what are we going to do today then? So we're in a position now to attach the stepper motor driver board up, which is here. Let's try and get it closer. So I'll sit it like that. Actually sit it like that. It stands up okay. And plug in the stepper motor driver cable. No, stepper motor cable. Sorry, this is the driver. So what I've got so far is the firmware for the stepper motor. There you go. This is the stepper motor driven antenna switch. Right, that's what we've got here. You can't see it, why not? Does this go any higher? No. That's as high as it goes. What a shame. Okay, so is it time to alter this camera? Or do I bring another camera in? I don't know. I can hold it up. Anyway, let's plug it in. So I'll give it 24 volts, 12 volts. And we need 5 volts for the controller. It's already moving. Now this is making the sounds and the movement for a stepper motor driven antenna switch, which is not what we want for this one. Let's hold it up in the air. Let's try and get untangled. So let me see if I can hold it. There we go. So we've got that there, and I'm about to press the button there. I can. No, it's only moving a tiny bit because it's geared, and it's still moving as though it's switching a stepper motor for an antenna switch. So I can press the button. Now it's doing a sweep. Now this sweep was the old sweep for the stepper motor driven switcher. So we don't want that on this particular one. We need to work out how we're going to turn the rotator to different angles, and I'm holding it the wrong way up so you can see it. You can't see it. I suppose if I put something on there, you'd see it moving. Now what I haven't got is, I haven't got anywhere to sit that. It's supposed to be bolted with this bracket onto something. So I still haven't got that function, so what I can do is lie it down. Just like that. You can see it moving, sort of. Hang on, what about if I bring it over back a bit? Is that better when it's back a bit? Yeah. And we need something on the end, a sticky label or something. Or something on there so you can see it pointing. Right, so we'll use a bit of duct tape. Let's get a bit of duct tape and make an arrow. Or do I make a 3D printed one and put the brass inserts and bolt it on? I could need a representation of an antenna, don't I? So I'm tempted to make one. Could make a beam, a pretend Yagi, stick it on, scale down. Yeah, let's do that. Let's let that carry on running anyway. Right, let's get. Oh, I haven't loaded the program. That's a shame. Let's just run that up before switch over. So, obviously the belt's on show. We're going to keep the enclosure for the electronics and the stepper motor, and then we need to make a bottom to fit around this, just to, I don't know what for really, but just keep it contained. So a bit of a tray, like a, I don't know, just a cover, dust cover. Right, I'm just loading up antenna rotator. Right, it's loaded. Let's get back over to it. Right, so we've still got the wrong wheel on this now. So I might as well. Do I get rid of that wheel? Let's hide that wheel. Right, do we need that wheel ever again? I don't think so. Oh, that's not the real wheel anyway. That's only a representation. Let's get rid of that wheel, we're not going to use it. We've superseded that wheel. So that's what the new drive shaft looks like. It's got this flat on. I haven't, because I've downloaded the model for that other wheel, which is this one here. That's the one I've downloaded, because I tried to make it, and to do all this, it wasn't working out good. So I thought the quickest way is just to make my shaft fit this. So that's what I did. Anyway, so I can't show you that. I can show representation though, I suppose, if I knew what size it was. So, yeah, we've got the stepper motor, so we're going to need something to represent. Yeah, we need something. Right, okay. Tell you what I'll do. Let's do that now, because otherwise it's gonna throw me out forever and a day. Right. Let's do that then. So I'll measure the one we've got here. Roughly measure it, and it's got 50 mil. 52 mil. Okay, so it's 52 mil. Let's just start up here, why not? Let's go 52 mil, so half of that is 26 mil. 26 mil, and it's got a so it's got a 1 mil. 1 mil of that. Then it's got a oh, let's just come in at, oh, I don't know, 1.5 mil, and we'll go up. What's that? 9 mil. Then we'll do another one. Another one of these at 26 mil. So then we'll come up 1 mil. Is it 1 mil? Yeah, 1 mil. Okay, so we've got this representation of the wheel, and we know it's got a 12 mil shaft. No, it's just got a. No, it's got something else on it. Before we do that. Say 40 mil. So we want a 40mm on top of that. Okay, and that needs to come up, whatever the length of that is. $9mm. 9 mil. Right, okay, and then we want in it a 12mm bore. That needs to go all the way through to the bottom. That's it. So let's make it into a component. It's not quite finished yet. That's it. I used to name components, but there's no point. So we've got that, and obviously you need some holes in it. Yeah, so we need a square hole. So if I do, we've got the shaft there, so if I just sketch out, let's put some lines on.
Checking access, mobile.
Oops, what's it doing? Right, it's not going to let me do that, so I'm going to have to draw it like this. And
Mike 9, Juliet, Romeo, India. This is Mike. Whiskey 7,
5 mil.
Lima,
Yeah.
Yankee, uniform. You getting through alright, mate?
5 mil. And we want
Mike
a
9,
centre
Juliet, Zulu,
line.
India. Thank you for coming back, Mike. I'm not sure if I get the call sign correct. Sorry about that. But thank Thank you for coming back.
I think that's about 8 mil. So we go this way 4 mil. And this way 4 mil.
No problem.
Join up with that. And join up with that and get rid of that line. Get rid of this one and that one and this one. Right, so we want that to be cut that, paste it in place, and we need to just go down. I think we just have to go down. Hang on. So I want to go down to there. That gives us our place for our nut to fit, and then we also need to create an M4 so we need a to come out up to here probably. So we'll have to intersect the faces with the model for this bit. Let's just do that. Intersect the face with the model, which will allow me to delete certain stuff like that. Okay, so I've got that. We need to carry on deleting stuff. Can I get rid of that? Yeah, and that. Okay, now this one's not so good because we've got to go right through, so I'll have to cut this off, come out and paste it in place, and then undo the paste, and then paste it in place, and then push that through. Oh, well, let's just get rid of it and put a new one on. Right, so it's push that through all the way to there. And we've got to intersect the faces with the model again. That noise you can hear is the... Hang on. Intersect the faces with the model. Right, should be able to delete that rest of that now. Yeah, so we've got our screw bolt that can go in with our nut. Okay, what's we looking at? Right, that's that bit done. Very good. Now, we've also got the same again. About 110 degrees. A bit further, so we need another one. And the other one is towards... That's the flat. And the other one, so the flat is there. And the other one will be somewhere like that. So if we can grab that again, somehow try to grab it like that, copy, paste in place, and turn it. Let's say we want to turn it something like this. 125, what's that? 135, is that about right? Yeah, that could be it. Right, so we put one at 135. We need to grab it. Oh, we need to cut it, put it in the model, Now we need to intersect the faces with the model, and we should be able to cut it out. Alright, whatever that is, that's going on there. Right, so we should be able to okay, so we should have cheated a bit, and yeah, that's it. Right, so we've got it all done. Very nice, it is too. Let's give it a little bit of a step. Give it some ergonomics. There we go. Right, that's pretty much it, apart from the teeth. I don't have any teeth, so does it matter? Maybe it matters, maybe it doesn't. Let's see if we can put some teeth. No, leave the teeth for now. Right, so now we want to push that down. We want to grab that and bring it down, just down in that direction to there. We're going to need X-ray to get at it. Oh no, it's got to come down all the way to there. Right, is that good? Yeah, that's close enough. Right, out of X-ray mode. Yeah, so you can see that the flat is there, and so we need a fixing, an M4 fixing. But you can see that drive belt will line up with that, which it does. I can't draw a drive belt, unfortunately. Or maybe I can. Maybe I can. Or maybe we're not going to bother. No, we'll leave it like that for now. We'll leave the fixings for another day. Get on with some more work. I can put a fixing in another time. Okay. So that's what we've got. And there is facility in the end for a brass. Hang on. I'm gonna have to give that a pulley. I need to say it's a pulley, don't we? Step of cover. Right, I don't have a pulley. Let's make a new one. Large pulley wheel. Okay, large pulley wheel. Okay, so turn that off. Turn the large pulley wheel off a minute. Right, so somewhere here, I can't see it now. Let's try and go into this. Somewhere there's a... I thought I spied a brass insert. There it is. That's where the old one was, so I need to grab that. How am I going to grab that? Ah, got it. That's how you grab that. Oh, I've got to bring it up. Just bring it up. Oh, it needs to go there. No. What's going on? Alright, that's weird. Weirdness. Okay, let's give that a try. Close enough? Yeah, close enough. Okay. Right, that's our brass insert on the end of the shaft, so it put the pulley back. The reason we've got that is because we might want to attach some kind of rotary encoder or something to the bottom. So let's get the right way up. So we're the right way up now. Why have I got this bolt here? Do I need that bolt there? Let's get rid of that bolt. Right, so we've got our pulley wheel now. Potentially we could put some kind of encoder attached to it. Whether it would be a magnet encoder or something, I don't know, rotary, some kind of encoder. So, we're going to need a home position. Going to need to work out some kind of accelerometer chip or something that knows which direction it's facing. So, obviously you've got your attachment at the top for your whatever you're going to attach to it, drive shaft wise. Then you've got to have an equivalent down here, something will bolt over here to be able to turn with this shaft. So yeah. Anyway, right, let's quickly have a look at the thumbnail. Let's just save that. Save that. This is still going. Let's have a look at this. So I can touch the heatsink. It's not burning. It's not hot. It's just warm. So I look at the stepper motor. Yeah, it's just slightly, not even warm. It's just warm, tiny bit. Right. So what do we do next? We need to search for some kind of rotor. We're going to work out how we're going to find out where we're facing. Right, let's do a chat GPT. Oh my god, sorry. Apologies in advance. A chat GPT. We need to tell it what we're trying to do. Making a 3D printed antenna rotator. The rotator stepper motor driven with a 22 teeth G7UIV pulley onto a, I don't know how many teeth are on it. No idea. How do I count them? Say 50. Let's just say 60 tooth. 60 tooth larger pulley wheel, which is fastened to a fastened to a shaft has bearings like a drive chain or powertrain. A drive chain, i.e. prop shaft. Also 3D printed. What I need is something to tell my ESP32 controller which which direction the antenna is facing, i.e. north, west, etc. degrees. I can mount an encoder stroke accelerometer to the end of the drive shaft. The ESP32 will drive the NEMA 17 stepper motor. I also need to control two NEMA 17 stepper motors from a single ESP32. A closed loop azimuth rotator with a great ESP project. The key piece you need to solve are position, feedback, absolute direction, driving two-stepper motors reliably, keeping everything synchronized and accurate over time. How to know antenna direction, important part. You don't want to rely only on step counting. Missteps will ruin accuracy. You need absolute position feedback. Best option rank, magnetic absolute encoder recommended. Mount this directly on your final output shaft. Example, cheap IC, high precision SPI. Right, this is why it's ideal. Give absolute angle, no homing required after power loss, not affected by tilt gravity, works perfectly with rotating shafts. How to mount: magnet on shaft end, sensor board fixed nearby, non-rotating. Okay, that's good. Align magnet carefully. ESP to I2C or SPI, that's good. Read angle continuously. Right, optical mechanical quadrature enclosure. Incremental. Oh, it's the second option. No, we don't want downside, so we'll leave that one. Accelerometer not recommended alone, only measures tilt, not rotation. Unless, right, okay. Alternative magnetometer, compass sensor, example. Gives heading related to Earth's magnetic field. Con, sensitive to interference, motor windings, metal, needs calibration, less precise than encoder. Good as a backup, not primary control. Okay. Gear ratio math, your setup. So if you step 200, so it's doing a bit of extra for me there, that's okay. Driving two NEMA 17 motors with ESP32. Can easily handle two motors. Use proper stepper drivers. Right, I've got the drivers. Each motor needs step pin. Yeah, enable optional. Okay, so we can swap the enable. So, control approach, use a non-blocking library. It's timers for precision, right? Example pin setup, la la la. Motor, basic concept, motor 1 azimuth elevation. Now, closed loop control, this is what you want instead of moving on those. La la la. Control loop, Persuado logic. Alright, don't worry about the logic. Oh, no logic. Mapping direction. North 0 degrees. East 90. Yeah, okay. That'll be easy to sort out. Power consideration. Very important. Do not power motors from here. Oh yeah, not going to do that. Practical build advice. Add a home limit switch. Even with encoder. Use bearings. You already have. A home limit switch. Well, we can home it to one of the degrees if we're going to do that. Keep encoder wire away from motor wires. Add capacitors near drivers. Recommend setup best balance. ESP32s, NEBA 17s, 2 DMC 2209 drivers. Encoder on output shaft. G22 pulley system. Your design. If you want the next step, right now there was something that I picked up the other day, an AS5600 encoder. Right, what did I pick up the other day? Oh, let's shut this off. Let's just stop this making a row. Switch that off a minute. Right, I picked up some weird things. What did I do with them? Right, I picked up these. I don't know what they are. Wouldn't it be good if these were Z probe car bed? No, that's not good. Right. So what I need to do now is how much is and where from the AS5600 Alright, you can't see that. Okay. Cheap, £4.10. £2 to £5 from AliExpress. Paya RS components. Right, okay. Magnetic encoder. Oh, Adafruit do one as well. That's good. And that's yeah, Stemma QT driven. That's good. got a Stemma QT on the board. Right, okay. Are these these, what are these ones driven? Right. Okay. What version? Magnet included. I2C. Yeah. Where to buy? What version should you buy? Important. 12-bit angle sensor. Fits your interrogator perfectly. Right. Okay. So, how does it actually work then? What do? You fasten it somewhere? Right, it's gone ahead and printed loads of stuff off I never asked it to. Show me example of use. i.e. how to mount and magnet and PCB. Good question. Right, rotating shaft, magnet glued to the shaft, or push into a 3D printed part. 1 to 3 minute gap. The piece is fixed, does not move. Real mounting example. Right, so it needs to go over the chip basically. Magnet sits directly above the center of the sensor. Distance. Magnet must be diametric type. Side to side pole. Right, so has somebody done something with one? I got you. So I can easily mount that to something. Yeah, that would be a piece of piss. Piece of piss. Piece of piss. Piece of piss. Right, what's that? I2C level shifter. Right, okay. Yeah, I've already got that built in, I think. Yeah, I have. Best mounting method for your antenna rotator. Don't worry about that, I'll sort that out. Right, so I need one to buy, a common one. It's gone into too much detail. Can you source one cheap and lots available? Right. UK friendly, yeah. £2.60. Now, so if I use that, now I also want the stepper motor driver. Well, that'll be separate. Right, so one of them, Amazon, available from Amazon. Right, then it says carry identical boards. What's it keep talking? Keeps iterating. Amazon link. £5.49. Shit. Right, where's this link? Is that it? Can I click that? Ooh la la. $5.49. Get the magnet with it, jumpers, VCC out and ground. What's the out for? Why have got an out? What is the out for? The out pin confuse. What is the out pin for? Gives angle. The out pin gives the angle as an analog voltage, or instead of using R²C. So there are 3 ways to output angle. Yeah, okay. Why does it print lots of stuff? I didn't ask it for all this anyway. Right, so we've sorted that now. Can you design a KiCad PCB to drive 2 stepper motors? Yeah, 2 NEMA 17 stepper motors. Would they be driven to be driven by ESP32? Would it be I squared C or SPI, etc.? Yes, actually the kind of product where, especially since you're building a proper antenna, I can absolutely design one. First though, I'd like to explain the right architecture because the choice matters a lot. Blah blah blah. Steppers are normally controlled, are not controlled by a script. In most design, this just click, yeah, directly. Best driver choice, so very good. Step driver enable UART. Budget options, I've got some of these. Still very good. Okay, I'll use the smart cheap ones. Does belong in your design. That's for the angle. But for the stepper motor, right, so we need, yeah. So, right, hang on. Oh, I've got 3 messages left. Can you utilize a Larlin 10-way TFT touch screen connector, as I have an expansion 10-way connector on my existing PCB. Right, that's actually a smart move. Your existing piece or as expansion. Let's reuse pins effectively designed. Right, what you'd likely have a 10-pin TFT, MOV TFTs. Yeah, that's it. Grounds, VCC, chip select, DC, MOSIs, SKC, touchscreen. Good news, SPI won't conflict with steppers. Stepper drivers use step do enable. TFT uses SPI. Coders use, yeah, that's okay. Suggested full signal layout. This would integrate your TFT header cleanly. That's good. SPI shared. TFT display. Larlin 10-pin. Optional touch controller. Yeah. I squared C bus for the encoder. Stepper will use stepper 1 motor A. Yeah, stepper direction. Yeah, very. ESP 32 pin assignment recommended. This matches typical Larlin SPI layouts. So we can use. That's taken up by the SPI. The encoders are separate pins. The stepper driver 26, 27, 14. That layout usually works well. Right, and I can't remember which pins I'm using. I could have a look. Let's have a look. Let's open up KiCad and have a look at what pin assignments I've got it connected to. Right, just loading it up now. Let's get it over here. This is the main board that I use on all its platform controller, basically. It's my platform controller, so let's have a look. Not gonna make another platform controller. I'm gonna use this one. Right, here it is. This is the one. So it's this edge connector. We've got I2C down here to drive the encoder. We've got up here the. Actually, it tells you where they're connected to, doesn't it? No, it doesn't. Right, this is the 10-way Larlin TFT and touchscreen connector. So we've got to work out older version of KiCad here. So what? So what? Right, so I've got to work out if I can see where they go to. I think they're all on the top, so we could lose the bottom layer. It's a bit confusing to look at. Right, so we've got touchscreen chip select going to pin 12, GPIO 12. Now is that one it was telling me to use? No. Oh yeah, direction on 12. Fair play, fair play. Right, so the next one is TFT chip select, which goes to GPIO 27. No, hang on. Can't see it. This one here. Can I just select it? Can I select that with an arrow? No. Right, it goes up here and it's on 14. So let's see if it's saying that's one. 14, yeah. Okay, fair enough. It might have done all the work for me and checked it, so that's good. That's good. So far, so good. Let's go and carry on. So the next one is that's 3V 3. That's no good to us. SK, that's part of the SPI. I don't want to really use that. Nor MISO nor MOSI. TFT DC 4. That goes to DC. TFT DC. Pin 27. 27. So yeah, there's 27. So far, so good. Carry on. Right, next one is TFT reset. Okay, so that's on. It goes on to the blue. Blue up here, across here. Yeah, still going in the right direction. It comes up to contact.
This is G3VM, serving the West Midlands.
I must have lost that. I lost that idea. Contact. No, I've done something wrong, haven't I? Where is it? Contact. Oh no, there it is, look. TFT reset. GPIO 33. It's not showing 33. Maybe I didn't need that one. Okay. We'll ask it about that in a minute. So GPIO 33. Reset. Ground, we've got TFT LED. Don't know what that one is, so we'll look. Goes up there, round to here. Lost it again. Goes up here, round here. Up there, round to there. TFT LED, yeah. And it goes up to 32. GPIO 32, so it's not telling me about them. So 33, 32 and 33. Right, hang on then. Ah, it doesn't know that what I'm using for those signals, that's why. Yeah, because I haven't wired mine exactly the same. Or have I? No, I have done, I think. So, those are all TFT reset on 4. Yeah, this is not the typical. Right, so there's certain things. Yeah, because I must have changed my Mossy. I don't know what I'm using. Yeah. Reset. TFT reset on 4. Right, it doesn't know what I'm using, does it? That's a typical Larlin SPI. Right, let's have a sip. What's up to HF? Is he gone?
Roger, Sierra Papa 3 Bravo, Oscar Golf, Radio 6, Oscar Echo Radio. Bogoslav, good evening, my friend.
Right, so it doesn't know what I've used. I suppose if I open up, I'll have to open up the firmware. We did say we were going to do some firmware today. Doesn't say on there, but it says on the title, firmware work. Yeah, so that's okay. What's this? Right, so that's our boilerplate, so we need to go over to our actual engine. Let's get over to the engine and try and work out what we're using. Display TFT. Right, so we've got some drivers going on here. Have I got it on the INI? Is the INI? Right, so TFT display. Oh, I haven't got it enabled, have I? So I've got... Where's my Larlin? What's it doing now? Stop doing stuff. Right, so we've got the display. If I tell it temporary, hang on. Tell it it's got TFT display. Put that on. Right. And what that'll do is it'll allow me to, yeah, highlight the, yeah, it's not caught up, has it? Still doing something down here. Let it catch up. So I'm getting hungry now. Need me tea soon. Right, so touchscreen. Ah, here we go. Yeah, there's some information. Right, so Larlin 32, Node MC, yeah, Dev Kit 1. Right, so it's using the TFT 2714 33 as a reset. And we've got yeah, T watches and different displays. So right, so there's that, and then we're using the touch screen. driver is a different driver. So DC is 27, CS is 14. So DC we said was. Can I drag it over? I can, can't I? Yeah. DC is 27, yeah, that's good. That's how I've set it. And chip select 14 and reset 33. Chip select. Hang on. Reset 33.
Your signal 5959 super 5 modulation, very good. My name
Chip
is
select 12. Hang on. TFT chip select 14. Hang on. TFT chip select 14. There it is. Yeah. Yeah, that's good. So that it is the right one. Yeah. The TFT reset is 33. TFT reset, where are you? There it is. Yeah, 33. Okay, so it is the right stuff. Now that's only the display. Now we want the touch screen. Touch screen. So have we got it down here? Touch screen. Yeah, touch screen. There we go. Right, so if we're using the Larlin, there it is. Here's these three again. Chip select for the touch screen is 12. Right, and it's not saying. Must be where it initializes it. Hang on, let's see where it is here. Here we go. Touch screen. Chip select. That's all we want. So uses Mossy. Right. Okay. Don't work. I've changed that since. So yeah, it only touchscreen only needs additional chip select pin. Initialize the touchscreen. Let's have a look at that. TSD, yeah. So it's not sending any. If you go onto it, go to definition. Begin. Go to definition. No, it's not going there. Right. Okay, that's fine. So it looks like we can just use the SPI. So if I go on to 3D model, wherever that is. Where's the I haven't used this for ages now. Where's the 3D print? 3D viewer. Right, yeah, we can see the PCB better on the 3D viewer. So yeah, we've got this controller. We've got Stemmer QT I2C, and we've got this SPI line TFT, which we can utilize to connect up our stepper motor driver board with a ribbon. And this is a ribbon that plug both ends. So all I've got to do is design the board and put the two stepper motor drivers on it with this connection, and then I can just use this to control the stepper motor driver. Alright, that'll do. That's all we wanted to prove. That's all we wanted to prove. Hang on, what have we got now? Right, so we can do it easy enough. Now I told it to design me one, but it never can design you one. You've got to do that yourself. It'll make a complete mess of it. So I know what I've got to do, and it's saying I'll just use the drivers already using. So I'd have to get the schematics. Well, the data sheet for the driver, and make two up. So yeah. So I need to buy that basically. AliExpress. Do we buy it off AliExpress and wait weeks, or do we get it off Amazon? I think we got to get it off Amazon.
Uniform, Lima United, uniform, Lima United, please again.
Right, anyway.
Okay, actually, Daniel, okay.
Right, anyway, that's going to be a quick one. I don't know what else I got to show. We've done what we said we're going to do. No, we haven't altered the firmware yet. Yeah, we haven't altered the firmware to make it rotate, but there's no point in doing that. Let's just plug it back in again. So we've got this. This is what we've got so far, if you missed the first bit. Belt, 300mm belt, NEMA 17 motor here, 22 teeth pulley, GT2, a custom 3D printed pulley wheel on a 12mm bore attached to this converted shaft, and it fits onto this bearing. You've got an axle bearing and a thrust bearing, so they both act as thrust. Then you got 3D printed. Got to put some brass inserts in here and mount whatever else onto it. So I need to 3D print a little antenna really, and some way to hold this up. The idea was to fasten this shaft to something, so I could sit it like that. But we could hang it over the edge like that, and then 3D print something here, like a little representation of a Yagi, and connect it to there, so at least we can see it's rotating. Yeah, we'll do that. Yeah, so we'll do that.
Радио 2, Сергей, Антон, Федор, прекрасно. Так, ну антенна на запад 5-6 принимаю.
Anyway, turn that off. Right, so are we going to do anything today? Yeah, we could do. Let's do something. Let's create a little representation of a Yagi that we just bolt to the top of this. So what we want to do is grab hold of this. It needs to be all in the same place. So we'll copy the top of that. Paste it in place. Just grab it. Make a component. Lift it up. How big's that? 6mm, so 7mm. Copy that up. Move it up 7mm. Okay, so we've got sort of that. Now we need to sort it out. So we've got no centre bit on it. We only want a small flat bit. So we need the hole so we can get rid of. Let's just get rid of that. And we don't need this bit at the minute. Or that bit. And we don't need it that thick because it's only a representation. So, well, we know it's 6mm, so we'll just read. I've got to bring that down 0.5 and then delete that and push that up about 5mm. Up 5mm. Is that too thick? That's okay. That's it. I'm just going to screw it down to it. I don't need the bevel for this. It's only a cheap representation, just so I can see what is going on. Oops. Delete that one. And we don't want these anymore. Alright, and we're just let's get rid of these. That's the inset, brass inset. Oh, because it's on there. Look at that. Look at that. Who'd have thought it would do something like that? That's a glitch, SketchUp glitch. Yeah, that's okay. So we want these off a minute. We just want the whole position, so right, so we've got a solid disc, and how big's that disc? Let's have a look. 2mm. I don't think we need it 2mm. Let's just do it quick. 1mm. Let's make it 1mm. It's going off my screen. Right, 1mm enough. So we're going to use what the hell? So these are yeah, M3. They're M3 brass inserts, so I just need to go in here. What's it doing now? Why didn't it let me? That's weird. It won't reference it. Why not? What the hell? Well, that's as weird as it gets. Right, so we've got... Oh my god, it's not letting me. Hang on. Right, that one does let me. Look, see that? So it's M3, so 3.1. So let's go 1.6. And that'll give me 3.2, that's okay. Let's get rid of that one. 1.6. 1.6, and now is this going to let me do it? No, this one's playing silly buggers. Look at that. Right, let's cut it. Paste it in place. Cut it. Paste it in place. Now will it let me do it? No, still no. It just hates me, doesn't it? This program hates me. Right, 1.6. Right, so we've got all the holes we want now. So we can push that through. Push these through. It's just going to fit to the top of this shaft that I've already made. Right, so that... Right, so that's just going to bolt to that shaft there. So I need to bring that down to there. That's it. I'm going to put some pins in, but I need to make a little Yagi. It's only going to be a 3D printed Yagi, just so we can see it moving around and pointing to stuff. That's all we need. So how do we do it? Let's just do it. It doesn't matter how we do it. Let's go that way. Can I look at it from above? Yeah. Here we go. So I'll just create a Yagi.
Oh, let's see how.
I'll just go this way. I don't know how far. 150 mil. 150 mil. That's a lot, isn't it?
At the moment, I can't get in on Echolink. It's just not working, my system at the moment. Peanut's working alright, but Echolink is not.
Right, so we've got that. We've got 150 mil.
It's about 18 miles away from me,
Shit.
but I'm sort of above it, if you know what I mean, so looking down on it. So we've got quite a good copy on this one. This is MB79KL. Obviously, we've spoken before there, but nice to catch you this evening. And thanks very much for the report. You're coming through very well yourself. The radio is a little Hyrule IC980 Pro. Which I treat myself.
Right, so we've got an indicator or a pointer.
It seems to work very well.
Just a pointer.
M3HNL.
Do we want it to look like a Yagi or just a pointer?
Yeah, well,
Let's make it into a Yagi, why not?
Yeah, the call sign.
I've no idea how to make a Yagi, so I'll just guess.
Charlie Radio, M5SC.
I'll just guess so.
In the land of Robin up there, my friend. Yeah, you definitely
I'll have
make
a
it
small one. Oh, I don't know.
On that note, mate, don't see. Take care.
I don't know. Let's just draw something. So we'll go out this way. I don't know. 50 mil out this way.
Well, that's nice to know we're getting all right on this one. I know exactly where it is. It's, all good stuff. Okay, so, have a good evening, Stuart.
50 mil out this way. We'll go in. I don't know.
This is M3HNL. Mike 3 Hotel, November
10
Lima.
mil.
Listening and standing by on HubNet. For any calls.
$10 mil to that, and 10 mil, 10 mil. Alright, I don't know what this is, it's gonna look weird.
Roger, BQRM, sorry my friend. Mike Italy 0 Golf Tango Alpha, Steve. Good evening, Steve.
Okay, now we've got a hollow, no we're alright, we haven't hollowed it out.
Big QRM, QSL my friend, my back to you.
I've no idea, I'm not gonna look at a Yagi, I'm just gonna play, just pretend. Wouldn't mind making one actually, all 3D printed bits to make one. So instead of doing this again, we'll just copy that.
This is M3HNL. Mike 3 Hotel, November Lima. Listening on HubNet and standing by for any calls.
Right, so we'll just move that over. I don't know. Move to there. Let's say 60 mil, and then we'll have a copy of that. We'll make it a bit closer, like that. Reflector. Let's just do that. Right, okay. So we should be able to just fill that in there and there.
Good luck and good DX. Бараsalama, шукран, до свидания. Again.
Alright, we'll get this on the go.
Victor, November, Japan, call again.
Oh. Oh, I know what's the matter. They're not part of the model yet.
Victor, November, okay, Japan, November, Japan. Italy 00, Victor, November, Japan.
Right, now they're part of the model.
56, my name, Dima Dimitri.
Okay. I'll make it look a bit more like a Yagi in a minute, or make them bits longer. Right, is that it? Yeah, that's it. So we want a small. Let's just make a small one. Otherwise it's going to get in our way. So we'll go this way. I don't know. What's that say? About 30 mil that way. We'll go this way, 30 mil. And we'll come this way. Come that way, I don't know. 15 mil. That way. 15 mil. Right, so does it look like an aerial, sort of? So I think we need to move that back a bit. Something like this. Oh, looks weird, isn't it? That'll do. Right, so we've got this flat thing that we can bolt to the top. Oh, I've got to be able to fit it in the printer. Hang on. 208, that'll fit in. Tell you what, let's make it a little bit shorter. Save on the waste of print. Let's make it shorter. I suppose I ought to really look at a Yagi and find out what it's all about. Anyway, there it is. Right, let's just print that out. Let's print it out. We'll probably make this in a red colour or something. On the count that I've run out of white ABS. So stepper motor, enclosure, no. Pulley wheel, is there a shaft? Where's the shaft? Race, pole, we've got a pole. Where's the pole? Oh, pole, there it is. So it's the pole. Okay, so there's nothing really left to say. Yagi. Right, so I've got a Yagi. I think I need to make it into a different colour. Let's just call it red, seeing as I've got some red. We've got some red. That'll do. I'm not going to bother to go around all the rest of it. That's fine. Right, so we'll put some fixings on there, and then at least we can spin it round. I think I'll just change it. Let's spin this round. I don't like that position there. Why won't it get it? There it will. Right, so this is just while I'm testing it, so I can see if it turns. Now we could do with knowing which is north, east, west, south, you know, whatever. I suppose, yeah, I could do with some kind of thing bolting on there, but anyway. Right, never mind. Let's save that. Let's get this printing. Hopefully it won't take that long and I can have my tea while it's printing. So I'll go back over to here. Okay, import. What did I call it? It's gone. There it is, Yagi. Okay, and what colour? Red we said, didn't we? Let's change everything to red. Oh well.
принято, Игорь, прекрасно, спасибо. Ну, QSB станция практически до нуля ушла, тем не менее, кто разобрал. Вертикал, четвертуха.
Well, it's only thin, so it won't take long to print. Let's make it go that way up. Hang on.
УБ-2, еще раз.
Oh, that'll do.
Федор, Дмитрий, Люба. Так, отлично, Александр, отлично.
I don't think we need any support or anything. We don't need nothing. Let's not have anything. Yeah, let's not have any of that. Strength, it can just be, that's it, normal, default. Right, slice the plate up. Did that quick, nothing to it. Print. Why is that off? Oh, let that go then, and
Антон, дробь, Мария. Так, расскажите, где, в каком море, как далеко. Радио Дмитрий 1, Антон, дробь, Мария. Олег,
right, I'll print that off then, and I will go and get my tea, and we'll call it a day, and I'll see you on the next one, probably. Just let this finish loading. Is it going to show me? Yep. Okay. Right then, yeah, so that's the end of that. So we did the enclosure and drive belt. Firmware work, we didn't do any firmware work because we're going to need the device, need to order the device that ChatGPT told me to order, which is this device here, this AS5600 magnetic encoder IC. I'll get the datasheet first and find out if it is going to do what we want it to do, and we'll design a little thing that fits this onto the bottom of the shaft. It's the magnet that moves, and this thing just gets held in place, so it'll be just suspended underneath from the, so it'll be suspended underneath here. So the magnet will be bolted onto a bit of plastic and fastened to there, and then something will be clamped off here to come down and hold this PCB underneath there, and as it spins it'll know where it is. I think it uses the magnetic lines of flux to work out. So it sits directly over the chip and just turns the flux in the magnet that it knows. Yeah. Okay. Now, to make this more low profile, instead of having a great big thing stuck off it, we could turn this around. Although we've got to reprint all that, so that'll be something we'll do later on. And this is actually black plastic, so let's colour this black. It's just going to stay black, that is, so let's just make it black.
Oscar Echo 5, Golf, Kilo, Lima. Good evening. Hyundai Rio, signal 5858. My name is Dimitri. My back to you. Okay, good luck and good day.
Right, let's get this painted black up. Hang on. Cleaning the nozzle, that's fine.
This is Mike Whiskey number 0, Romeo Hotel Delta
Strong mobile, returning to you.
Okay, Nikos, no problem. Sugar Hotel Hotel Yankee Echo, Nikos.
Slowly coming together.
Signal 5757 QSL.
Right, it's slowly coming together.
Dimitri is my name, QSL.
Whiskey 0 Romeo Hotel Delta Mobile, nothing good.
Okay.
Right, are we done? No, there's always one more. There it is. There's always a few more.
G4MUV, G4MUV, DG4SKN, I wonder if you're actually.
Right, is that the lot? I think that's the lot for that. And also this is black as well.
CQ20, CQ20, Radio 6 Ocean Echo Radio, Romeo 6 Oscar Echo Romeo, QRZ. Kilo November, call again. Kilo November, only Kilo November, please. Mike 1 Alpha Kilo November, okay. Robert, good evening, your signal 5959, my name Dimitri, QSL.
Alright, so this is a bit of maintenance work. Well, I don't know. Colouring in. Right, let's have a look what's going on over here. I've started doing the whatever it is, a Yagi. A Yagi thing. It's not even a Yagi, it's just a representation of a Yagi. So we can see which way the antenna's going. It's hard to see when it's just a round disc on top of the shaft, so it's hard to see. Right, are we done? No, not quite.
Okay, Stefan, you signal at the moment 5959 QSB 5657. No problem, very good response. Thank you very much, good luck and good DX. Пока-пока, до свидания.
Naskladamyo, comrade. Comrade.
Echo America, call again.
Naskladamyo, comrade.
CQ20, CQ20. Radio 6 Ocean Echo Radio. Romeo 6 Oscar Echo Romeo, QRZ. Echo Michael again. Golf 3, Oscar Bravo Mike, correct?
Right, this is taking a while.
Roger, Bravo Alpha Mike, no problem. Brian, good evening, Brian. Your signal 5757. My name Dimitri. My back to you. Okay, you signal at the moment 5959. Good luck and good day, Brian. Пока-пока, до свидания.
Is that it? I think that's it. Right.
Bravo Lima Delta, please.
Okay, let's get the right way back up again.
QSL,
Okay, so that's more like it. What colour did I make that? Black. I made it out of black. I made it out of black. It's a spacer.
Grazie mille, ciao, buon day, 73 by Carlo, пока. QRZ Radio 6 Ocean Echo Radio, QRZ. Sierra Hotel, please again.
Alright, that's it. Yeah, oh, no, there's always one more. Okay. Right, so we've got... That's better, it's not all white now. Right, so yeah, very good, very good. So we've got to make a stepper motor driver to go on there that plugs in to that port, and then we want the magnetometer. I call it a magnetometer, it's not really, is it? What is it? A magnetic encoder. I2C. That comes through here. And I've got no cable entry route, so we're going to have to drill a hole and put a new one in the model. Plugs in down here into this socket. That one there. Stepper motor driver plugs into this expansion socket. Okay. This all sounds good to me. Is there anything else? No, that's white. Everything else is white. That's good. Right, okay. Anyway, so let's just have a look at that. Let's put this into a position where we can see it next time. I think that needs to go the other way. I need to spin that round. That's it. That's it, just so I can get it into shot. Can't see the stepper motor there. Oh, I don't know. Maybe it needs to go this way, I don't know. Anyway, that'll do. Right, I'm going to save that. So I need to make a PCB. So I'm going to have to design. I need to design a stepper motor PCB with two outputs. One to go off to an antenna switcher to operate a stepper motor on the antenna switcher, and the other one operates this. Now, do I make it a three-way one? Yeah. Oh no, I don't think I've got enough ways for a three-way one. No, we'll keep it a two-way one. Yeah, we won't have enough pins, so we'll keep it a two-way one. Right, oh, this has only got 8 minutes left, so it won't take long to print that. Right, that's going to be it for today then. Thanks for watching, and I'll catch you on the next one. So that's been antenna rotator number 8, enclosure and drive belt. Can't go ahead with the firmware work. Done the show and tell. I can show you again, but it's basically that what's on the picture there. The show and tell will come when we get the little magnet board on the end and the stepper motor driver. A lot of work got to go ahead anyway, so that's gonna be it for today. 7-3, and we'll catch you on the next one. Bye for now. Dave's out of here. If I could work out how to get rid of it. Here we go. Ta-ra.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. That information is not available.